Greetings and welcome to Distilled. So, this is the first tutorial of Python. So, here we'll be discussing, in the tutorials, we'll be discussing a few simple chemical engineering problems that you could maybe apply Python to and you could solve those problems using Python. So, we'll start with a few simple problems and then as we learn more and more, we'll be discussing more complex and more interesting problems uh, to go further. So today, the problem that I'll be bringing to you people is uh, identification of the limiting reactant in a chemical reaction. So in one of my previous videos from chemical process calculations, I mentioned a technique for calculating the finding out the limiting reagent. So I'll just briefly uh, mention that technique over here. And I'll also put the link of that video in the description. And you can go ahead and uh, see that thing in detail. So, suppose if we have a chemical reaction, let's say AA plus BB gives CC plus DD, right? So, if you have this chemical reaction, so over here, small a, b, c, and d are actually the stoichiometric coefficients of the reactants and products, right? So to identify which of A and B is actually limiting, we calculate two ratios. The first ratio is a theoretical ratio, which is A by B, the stoichiometric coefficient of A and B, right? So we calculate the theoretical ratio. And the second is the supplied ratio. So we calculate the supplied ratio, which is the moles of A supplied, let's call them AS, upon the moles of B supplied, let's call it PS. And now we compare the two, theoretical and supplied. So if the theoretical ratio is lesser than the supplied ratio, right? In that case, the denominator is limiting. So in this case, B is actually limiting. But if theoretical is greater than supplied, then in that case, the numerator is limiting. So in this case, A, right? And if both of them are equal, then none of them is limiting, right? Both of them are supplied theoretically or in stoichiometric proportions. So yeah, so we are going to perform this calculation on Python. So the basic idea behind the solution would be that first of all, we'll get the stoichiometric coefficients of the reactants. Then we'll get the amounts supplied, right? After that, we'll calculate the theoretical ratio and the supplied ratio. And then we'll do the comparison. All right. So first we'll be getting the uh, stoichiometric coefficients, then the supplied amounts, then we'll calculate the ratios, and finally we'll be doing the comparison, right? And of course, over here, as you see, there are three conditions. So since there are more than two conditions, we are going to use if, elif, and else, right? So now that we have got the basic idea behind what we are going to do, I shall not remove this part. We move on to the solving or the coding part. So we'll open Python and we'll do the same thing over here as we have mentioned on this writing written material. So first of all, we'll get the stoichiometric. So this code is for identifying the limiting reagent. So first of all, we'll get the stoichiometric coefficient of A. So the stoichiometric coefficient could be an integer or could be a float value. So we'll say float input stoichiometric coefficient of A, and then we'll find for B. So we'll copy the same thing down. And now this is the stoichiometric coefficient for B. All right. After that, we'll we'll get the supplied amounts. So we'll get A supplied, and we'll also get B supplied. Uh, so once that is done, so the first and the second step is actually done. So now we move on to calculate the theoretical ratio. So theoretical ratio, let's call it T, is A by B. Then we calculate the supplied ratio. Supplied ratio, let's call it S, is capital A by capital B, right? And then we have to compare. So we'll say if theoretical is less than supplied. So now we are going to print B is limiting. Okay. Another condition, else if or LF, C is greater than supplied. So in that case, we'll print that A is limiting. And otherwise, if both are equal, then we'll just say none of the two are limiting. Okay. And we'll save that. And we'll run this. So for this exercise over here, what we are going to do, we are going to take a very simple reaction. Let's say 2A plus 10B gives something, whatever products. We are interested in these two, right? And we'll say that, okay, A is supplied, 10 moles of A are supplied, and let's say 50 moles of B are supplied. So let's see what happens. So we'll do that. And over here, we'll say stoichiometric coefficient of A is 2, stoichiometric coefficient of B is 10, supplied amount of A is 10, and supplied amount of B is 50. And we see that none of the two are limiting, which is quite fair enough because if you see the theoretical ratio in this case is 2 by 10, which is 0.2, and the supplied ratio is 10 by 50, which is also 0.2. So both of them are same, and therefore this condition satisfies. All right, let's rerun this. So with some different values. So instead of giving B supplied to be 50, I'll say B supplied is 40. And let's see if it actually gives me the result. So if I say that A is 2 and B is 10, and now A supplied is 10, but B supplied is 40. So in that case, B is limiting because theoretically 50 moles of B are needed for reacting with 10 moles of A. However, we are just allowing 40 moles of B to react. So yeah, that's there. So hope that actually helped. And this was a simple tutorial. See you in the next video. Thank you.